This video covers selectional restrictions. I'll provide an overview of the topic and talk about representing selectional restrictions, and then I'll move into a discussion of selectional preferences. Selectional restrictions are the semantic constraints placed upon different types of predicates. They dictate which types of concepts can fill the predicate's semantic roles. Going back to an example from a previous module, consider the sentence, "Let's eat somewhere near SEO." There are two possible parses and corresponding interpretations for this sentence. In one, you're referring to eating a place that's located near the Science and Engineering Offices building, and in the other, you're talking about eating at a place near that building. As humans, we're easily able to select the correct parse because we know that the theme of eating events tends to be something edible. That restriction, the constraint that the theme of the eating event must be edible, is a selectional restriction. Selectional restrictions are associated more specifically with senses of words rather than the full words themselves. This means that in cases where a word has multiple senses, each sense of the word might have different selectional restrictions. They also vary quite a lot in how specific they are. In some cases, they may create narrow constraints, whereas in others, they're much more generous with respect to the types of arguments they'll accept. For example, the verb to eat might constrain its theme to edible things, but the verb to sip might constrain its theme to edible things that are also liquids. We can represent selectional restrictions by extending the logic we used previously for event representations. For example, we might represent the verb eating as shown here. With this representation, we know that the predicate eating has agent and theme arguments, but we don't know anything further about what types of agents and themes those should be. If we want to stipulate that the thing being eaten should be edible, we could update our representation so that it looks like this instead. Then when we encounter new inputs, we can check to see whether they adhere to the specified selectional restrictions based on the facts from some sort of knowledge base. For example, let's say that we encounter the phrase, "ate a pizza." We could represent it logically like this. We could check our knowledge base, discover that pizza is in fact a member of the category of edible things, and therefore decide that the input phrase is reasonable. This is a fine approach for representing selectional restrictions, but there are also other alternatives. In fact, there are simpler formalisms that work just as well with less computational overhead. For example, an alternative approach would be to specify WordNet synsets as selectional restrictions on arguments. Meaning representations would then be considered reasonable if the words filling semantic roles were members or hyponyms of the specified synset. Whereas selectional restrictions are hard constraints, selectional preferences are soft constraints. Selectional preferences rose in popularity as it became evident in early word sense disambiguation work that setting hard constraints could lead to unreasonable or underperforming models. For instance, sometimes people deliberately violate selectional restrictions to communicate information figuratively, or sometimes they violate selectional restrictions simply due to the fact that they are employing negation. Selectional preferences are often formally defined as the difference between two different distributions, the distribution of the expected semantic classes, P of C, and the distribution of semantic classes for a specific verb, P of C given V. Greater differences between these distributions indicates higher selectional preference strength. Basically, the verb is giving us more information about the classes its arguments can fall into. One way to quantify the difference between these two distributions is by computing the Kullback-Leibler or KL divergence between them as shown in the equations here. The selectional association of a given class and verb are then defined as the relative contribution of that class to the overall selectional preference for the verb as shown here. The probabilities used in these calculations can be estimated from corpora based on the number of times a given predicate occurs with a given argument. When using very large corpora, You can also directly compute selectional preference as the conditional probability of an argument occurring given a verb for a particular relation, or even just by taking the log co-occurrence frequency of the predicate with the argument. So given all of that, how do we determine if the selectional preferences we've learned are actually reasonable? There are two main ways that selectional preferences are typically evaluated. One way is to use the selectional preference model to determine which of two words, a correct context word and a confounder word, are more preferred by a given verb, and then compute how often the selectional preference model makes the correct choice. The other way is to collect human selectional preference scores, generally by asking humans to rate the plausibility of different verb-argument pairs, and then check the correlation between those scores and the selectional preference scores predicted by the model.